Okay, great. Let's pick it up from where we left off. Excuse me. Um, where? No, we did that. Um, Quadratic. Yeah. Yeah. Okay. 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 Sorry, I was just copying that over. So, right. 193. So, for all epsilon greater than 0, there exists a delta greater than 0 such that if now x is tending towards 5 from the left, so x minus a, so x is used to be a negative, isn't it? Let me just a quick sketch here. 5, and it's tending towards 5 from the left, so x minus a is a negative, but it can't be too negative, so more than minus delta and less than 0. Okay, yeah, let's fill it in though. That's 5. Okay, and then we have f of x minus L, which is 0, needs to be less than epsilon. So let's see if we can find the delta to satisfy this. Absolute root 5 minus x minus 0 less than epsilon. So root 5 minus x less than epsilon. 5 minus x less than epsilon squared. Multiply by minus. So x minus 5 more than minus epsilon squared, or in other words, minus epsilon squared less than x minus 5. So the delta would equal epsilon squared. Let's check the answer. $193. Yep. 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 Yeah. 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 Epsilon squared. Okay, good. 194. Okay. Fx. That's fine. Okay, well, actually, just be careful because it's positive here. So for all epsilon greater than 0, there exists a delta more than 0 such that if x minus 0 is less than delta, and more than 0, I should say, then f of x minus the limit minus minus 2 should be less than epsilon. So let's see if we can find the delta that does that meets this. So x is positive. So it has to be for x minus 2 plus 2 less than epsilon. So for x less than epsilon, but we know x is positive. We're talking about positive x from 0 to delta. So x is less than epsilon over 4. So the delta is epsilon over 4. So as long as, basically, as long as your x is between 0 and epsilon over 4, then you'll be within epsilon of the limit. Okay, 195. Again, same deal, except this time it's like the first one, minus delta less than. So let's see if we can find that. Fx minus 3 less than epsilon. X is 10 to 1 from the left, so x is smaller than 1. So it's the first one here, fx minus 2 minus 3 less than epsilon. 5x minus 5 less than epsilon. 5 x minus 1 less than epsilon. But x, remember, is less than 1. So this is a negative. So it would be 5 times minus x plus 1. That would make it positive. Minus x plus 1 less than epsilon over 5. So x minus 1 more than minus epsilon over 5. So minus epsilon over 5 less than x minus 1 less than 0. So we found the delta. Now we have the situation minus delta less than x minus 1 less than 0. If we choose an x in this interval, then we'll be within epsilon of the limit of 3. So let's just check 195 epsilon over 5. Yeah. Delta is epsilon over 5. Delta, where's it gone? Epsilon over 5. Okay. All right, that's good. Okay, got the next one copied here. Right, 196. So to prove this limit, we have to say for all m greater than 0, there exists a delta greater than 0 such that if, I'll write the if in, if x minus a, which in this case is 0, is more than 0 but less than delta, then fx is more than the m. Let's check it out. So we have 1 over x squared more than m. So that means 1 over m is more than x squared. Or if you prefer, x squared is more than 1 over m. So that means root 1 over root m is more than x. So x, yeah, I guess because I got rid of the square root here, really perhaps I should have the absolute sign in here. Yeah. No, Stephen, be careful. I really messed that up. Sorry, I'll do that properly. Apologies. I made a careless mistake. So I'll have 1 over m minus x squared more than 0. I'm annoyed at myself for making that mistake. So that's 1 over root m minus x times 1 over root m plus x more than 0. So that means that x is between minus 1 over root m and 1 over root m, which means the absolute value of x is less than 1 over root m. So we can see that the delta is 1 over root m. Okay, good. 197. Okay. Let's try again now. Same situation. Fx more than m. So we have 3 over x plus 1 squared. We need that to be more than m. 3 more than mx plus 1 squared. So take that over. So now we have root m times x plus 1 minus root 3 times root m times x plus 1 plus root 3. Be careful with my brackets. Is less than 0. So that means root m times x plus 1 should be less than root 3, but more than minus root 3. So dividing by root m, then continuing up here, I'll have x minus minus 1 is less than root 3 over m and more than minus root 3 over m. So then the absolute of x minus minus 1 is less than root 3 over m. So I found the delta. The delta is root 3 over m. And let's check the answer at the back. 197. Yep, root 3 over m. Okay. 198 now. Minus infinity, but the minus is here. So I feel like I just should say that's equivalent to saying 1 over x minus 2, but maybe we'll just go with the minus 1. The only difference this time in the definition is that fx needs to be less than m or minus m. Again, it's the same thing. For all epsilon m greater than 0, there exists a delta more than 0 such that if x minus a, which in this case is 2, is less than delta, then that means f of x is less than minus m. Okay, let's see if we can get that. Minus 1 over x minus 2 squared less than minus m. So that's 1 more than m times x minus 2 squared. X minus 2 squared, take the 1 over. So 0 less than root m x minus 2 minus 1, root m x minus 2 plus 1. So that means we'll have root m x minus 2 minus 1. No. Right. Less than 1 and more than minus 1. Minus 1 over root m x minus less than x minus 2 less than 1 over root m. So absolute x minus 2 less than 1 over root m. So the delta is 1 over root m. Okay, I think that's okay for 198. Okay. That's interesting. It's interesting word-based one. That's interesting as well. Okay. Yeah, okay. These are actually some interesting ones coming up. I think I'll save those for tomorrow. Yeah, okay, great. Okay. We'll leave it there for today. Thanks for watching, and I'll see you all next time.